Okay, there's a type of set operation called a Cartesian product, and it's named after Descartes. And it has something to do with the Cartesian coordinate plane that you're familiar with. This idea of like x and y axis, a space, a two-dimensional space in which you can graph, sets of points that correspond to solutions of equations, functions, that sort of thing. So a Cartesian product is a more general idea where if you take two sets, I'm just going to call them A and B, two arbitrary sets, you can do a Cartesian product, which is a cross, like that. And this is defined as the set of all ordered pairs, A comma B. That right there is an ordered pair. So that's kind of a new thing that we haven't dealt with yet in set theory, such that the A element of that ordered pair is just an element of set A, and the B element is an element of set B. And so any ordered pair you can make using something from A and something from B, anything that could do that, well, it would be an element of this set. So let's look at some examples. Actually, this is just really one example. If you take A equals the set 1, 2, and B equals the set xy, well, then A cross B, which is how you say that, A cross B is A Cartesian product with B. This is the set that's going to contain several things. Any ordered pair we can take by taking a thing from A and a thing from B. So one would be like 1 comma x, but we could also do 1 comma y. Or we could do 2 comma x, or we could do 2 comma y. And that's it. Those four things. So a couple notes about this. One, A cross B is not the same as B cross A, right? Because A cross B has ordered pairs where the first thing is from A and the second thing is from B. B cross A would have elements where the first thing is from B and the second thing is from A. So B cross A would have things like x comma 1. So you see how those are not the same, at least not in general, right? Like if A and B were the same set, well then, yeah, they'd be the same thing, but like in general, they're not. 2, the cardinality, sorry, I spoke that weird. The cardinality of A cross B is pretty clear if they're both finite. If they're both finite, then the number of things in A, that's like the number of choices you have for what goes in the first position. The number of things in B is the number of choices you have for what goes in the second position. So we can just multiply those together. So it'll be the cardinality of A times the cardinality of B, just like that. And that is, as long as both are finite. If one of them is infinite, well, then this multiplication might not be defined any longer, and so, well, never mind. But if they're finite, you just multiply them together. 3, this extends to any number of sets. If you can do like A1 cross A2 cross A3 cross ... cross AN. You can do any number of sets, Cartesian producted together. And if you do that, that produces a set of what we call n tuples or n tuples, depending on how you want to pronounce it. A ordered pair is a duple. It's two things. If you have an ordered triple, that's called a triple. Triple, that's where the word comes from. If you have 4, that's called a quadruple or a 4-tuple, and then that extends to a 5-tuple, a 6-tuple, a 7-tuple, however many you want. So it's basically an ordered string of something, of things from different sets. Tuples are one of the other fundamental structures you work with in computer science, at least a lot of languages. 4, note 4, A cross A, if you take the same element, Cartesian product with itself, that is denoted by A squared, like that. And also, in general, if you have a whole bunch of A's, like n factors here, if n of n A's crossed together, that is A to the power n. So exponents for sets means that you're taking a Cartesian product of that set with itself. So the familiar example that you probably have seen before is with the real numbers. When you see r squared, or sometimes we say that r2, this is r cross r. That is your xy plane. Okay, and if you're in multivariable calculus, r cubed is, R cross R cross R. That is the three-dimensional space that you get by doing, X, Y, Z, that kind of thing. So this sort of it's called real n-dimensional space. It's just the set of real numbers, Cartesian product with itself, some number of times to give you 2 dimensions, 3 dimensions, whatever.